The whole offshore yacht came about in 1988 and 1989 when we were just approaching the 10th anniversary of the disastrous Fastnet 79 race.
Jeff Pack, Yachting Monthly's editor, together with designer David Thomas, were part of the original group who explored the feasibility of a complete offshore yacht.
10 years later,
5 years on, this concept boat is to become a reality.
But the actual catalyst for this project was a sail in a modern production, what has subsequently become known as a sort of bubble boat or a balloon boat. A lot of volume, really a boat that should spend more time in harbour than ever it does at sea. A very popular production boat, and we went out sailing it in quite strong winds, and we found that the boat didn't have the righting ability, mainly because she had an iron keel and she had a very bulbous hull. She didn't have the righting ability to carry the sail required to overcome her own windage to get to windward. So suddenly we found in about a force 5 wind the boat was actually running out of steam. You couldn't physically set the sail you couldn't physically set the sail to overcome her own windage, because as soon as you set that sail she laid on her side and went sideways. And it shocked us that much that here was a major builder, a reputable designer, producing a boat which really was unable to carry on working in really a force 5, let alone perhaps a force 8 or a force 9, when really the boat's got to look after you. So we set about getting together a committee of people who we felt were probably the top people in the country, who could give good input into this design. We set out from the outset that the boat would never be built. All we wanted to do was create this ideal yacht in many ways, the ultimate cruising boat. We had no commercial restraints because we felt that the commercial element had been at the root of the bad turn that the yachting design had taken. So we, having formed this committee of experts, we then sat around the table and discussed what elements would be created into the ideal boat. And we wanted the boat to be realistic within our own readers' or within the reach of our own readers' thoughts. So we kept it at 35 feet. It was going to be a production GRP boat, purely mythical, as I say. It would go no further than the design stage. Shortly after that, Serious Yachts approached us and said they would be interested in building the boat. The rest really is history. We then Drummond then came along and wanted to build the boat.
I had followed with interest the series of articles in Yachting Monthly and recognised that this mythical boat was exactly what I myself was looking for. Having grown up with a folk boat, I'd found most larger production GRP yachts to be sadly lacking in many of this legendary little boat's qualities. I wanted a true blue water yacht for 2 to 3 people that above all would go to windward when the going starts to get tough.
Got the drawings from the designer.
Good.
And all the full-size plots. This is Phil, and that's Dave. Mr.
Morning.
Chalice,
Morning. Morning.
who's commissioned the Yachting Monthly Offshore 38.
So what have we got here?
These are all the full-size plots that have come from the designer.
From David Thomas?
Yes.
And these have been drawn by hand?
No, these have come from the computer. That saves us a lot of time. We don't have to full-size from a table of offsets anymore. We work straight off the plots that come from David onto our boards, and we then join all the dots up and then able to make the frames to start building your boat.
When Brian Jones of Sirius announced he intended to build a YM38 designed by David Thomas in steel, I knew the end result would be something special. With the Elizabethan, Hunters, Sonata and Sigmas behind him, and the British Steel Challenge fleet on their way round, David Thomas could design a boat that would measure up to many of YM's imaginary requirements. The strength of steel also attracted me. The extra security it brings is a great boost to self-confidence when sailing short-handed offshore passages. So, Brian, tell me, these are the flats that the frame's made out of?
Yes, these are rolled roughly to shape of the hull in each of the stations that you've just seen on the full-size plots on the board there. Once these are rolled roughly into shape, we then have U-sections that hold the T-bars into position when the boat's upside down.
Right, and these are obviously the T-bars?
Yes. These are a standard stock length, as from the rolling mills. Obviously not the full length of the boat, so we have to weld 2 together. 2 together.
And then the hull plating is welded to the outside of...
Yes, the hull plating is welded to the toe of the T-bar, the flat being the inside of the hull.
Right.
The key to building a steel boat with this method is to construct the skeleton of T-bars around the frames, which will, on completion of hull plating, be removed. This gives an immensely strong yet high-volume shape, which can be semi-mass produced. Here we see the longitudinal T-bar stringers being formed over the frames, which are held into position on a rigid base.
We've been doing quite a lot of development work on steel construction with Sirius yachts, and they had a very effective construction method with a lot of longitudinal stringering and plating continuously from keel to gunwale. And this produced very fair and very strong steel hulls. So strong that we used the same principle for the British Steel Challengers. People were just beginning to become aware of what's floating around in the oceans, and there'd been one or two incidents where yachts had been damaged by colliding with unspecified debris, and steel suddenly became something to consider.
I think another thing from the ocean cruising folks' point of view was that insurance for ocean cruising was becoming more and more difficult to obtain, and the idea of having a steel boat, you had a very nearly indestructible boat.
What you've got to remember is that that voyage had never been done before. Everyone said it was impossible, and I was advised not to do it and all sorts of things. So I was looking for, in my mind, what I thought was to be the strongest material. Hence the reason I went to British Steel, and I'm delighted to say they backed me, and we went round. And certainly when you come off the top of a wave, and it's very difficult to try and tell someone what it's like, but if you can imagine this boat crashing through the waves down the roaring 40s in very severe cold temperatures, it crashes its way through the waves, and then suddenly the wave rushes past, and you're left 14 feet up in the air, and suddenly you drop down this terrific bang, and water's crashing up all over the place. It's certainly when you touch the steel, it gives you a little bit of comfort. In my book, anyway. The big thing about steel is preparation, and as long as you prepare it properly, then of course the maintenance is kept to a minimum. Certainly nowadays, of course, it really is an excellent material. And fortunately, of course, I had British Steel, and I also had International Yacht Paints as part sponsors. And they've got a yacht called Courtaulds International going in the BT Global Challenge.
Do you think steel is a practical material for building a blue water yacht?
Oh, very much so, yes. If I was ever to go off and sail the White Blue Yonder, there's no doubt in my mind I'd go for a steel yacht, very much so. One thing which is quite interesting is that British Steel went out to charter some considerable time ago. The skipper, I wasn't the skipper by the way, got in a bit of difficulties, and the boat went up on the rocks. Now it pounded on the rocks for something like about 9 hours. It didn't split the hull, it got a lot of bashing, a lot of banging. There was no heavy equipment to lift it. It was pulled up the beach, it was left for about 3 years. Then eventually repaired, because remember, steel, all you could do is cut it out, and then repair it. So if anyone was to get into trouble and found themselves on a fairly bad beach or a bad rock somewhere, then you want to be in steel and not something else.
Keel configuration is perhaps the most debated area of design. David and Jeff look at the various options.
Struggling to keep its weight low. I think it's a bit shallow.
Yeah.
The half skeg rudder is a possible, but I don't like them particularly because of the drag at larger angles of helm.
Right.
Different kettle of fish altogether here.
Sure.
A wing keel. Now they have a performance that would be all right offshore.
Yeah.
And they've got the stability in the right place. There's 50% of the total weight of the keel in those wings.
Right.
And
then
then
this is much more of a conservative sort of, it's fin and skeg again, but it's not as...
it's a long fin, isn't it?
Yeah.
It's not far from what we're looking at, really, in terms of its aspect ratio.
And maintaining good directional stability. This boat has a full-length skeg, which is what we're talking about with the Offshore 38, isn't it?
But by golly, it's got to be strong.
Yeah.
And you can do that with steel.
So it's a good, safe, sound way of going about it.
That's the safest way of doing it.
Yeah.
David opted for a fairly deep fin for light blue, with a full-length skeg. Unlike the bolt-on cast iron affairs found on most production yachts, the YM38 has a fabricated, almost aeronautical wing construction of ribs and struts, with a base plate and heel cut from 20mm plate. The lead ballast is poured in at a later stage. The keel forms an integral part of the floors of the boat and must therefore be fabricated and fitted while the boat is upside down and before the placement of the lower T-bars and plating. The side panels are pre-cut from 8mm plate, which when welded to the base plate and ribs forms an immensely strong monocoque construction.
We've got enough fin keel, which combined with the shape we've talked about will make the boat run straight. The other thing that affects this directional stability is the amount of stem that's immersed. We've got a fairly deep stem. We don't pull the rocker of the boat up too sharply so that she'll run straight. We don't want a boat that will only run straight. We want to be able to change direction, and that of course is where the fin and skeg system helps in that respect.
Yeah, I think it's a misconception at times that people think because a boat has a long keel it will therefore run in a straight line, and they assume that because a boat's got a fin and skeg it's therefore going to be less stable. But I think there's far more to it than meets the eye.
Hello, Dave.
Morning, John.
Phil.
Morning, John.
Things have progressed since I was last here a bit.
Yes, they certainly have. Yes, we're getting on quite well now.
It's looking like a boat.
Yes, certainly is.
What do you think of this type of construction in comparison to a bolt-on precast keel?
I think it's a much better idea. It forms an integral part of the boat, and it means the whole boat is one large fabrication as such. It gives it a lot more strength. Bolt-on keels, you have got the problem that should circumstances be adverse, they can work loose and could result in somewhat of an accident.
The hull deck joint will not be made until the boat is turned over. The basis of that joint, however, is a solid rod running the length of the boat welded onto the end of each deck beam. This joint has been a problem area in earlier methods of steel construction, which included a conventional upright gunnel with teak or plastic capping and scuppers along its length. Light blue, like her British Steel big sisters, will have a more contemporary stainless steel tow rail set inboard with a rounded and immensely strong joint which will not trap water. The transom will be fully plated, and the cut-out end and sugar scoop will not be fabricated until the cockpit is constructed. It incorporates a Danboy tube and the Hydrovane self-steering gear as an integral part.
The transom is now ready for plating.
So this is actually the line of the transom?
It is, yes.
And how do you make the joint here between the plating on the hull and the plate of the transom?
We shall use a round bar like that. Almost the same idea as when we join the deck to the hull.
The hull deck joint?
Yes.
Yeah. Immensely strong, isn't it? This
It is.
rig here. It's unbelievable. Compared to a glass boat.
Yes.
6 weeks into the building programme, everything seems to be going well. So far, I'm very impressed with the skill and knowledge Sirius have displayed and the attention to accuracy. Although we are dealing with fairly basic welding and cutting techniques, Brian Jones's team keeps an eagle eye on every millimetre. This will pay off once the plating process starts. It's time to start discussing and ordering equipment and systems that are to be incorporated into the boat. We've already chosen the Yanmar 38 horsepower 3GM as our propulsion unit, which, as with all engines, needs a raw water inlet and exhaust outlet. What about water maker, heating, toilets, deck wash and bilge pumps? I want the minimum number of holes through the hull, and these must be in the right place and easily accessible.
With the hull, keel and skeg all in one piece, the plating commences. Each plate comes from the rolling mill in 3-metre lengths, 610 millimetres wide and 4 millimetres thick. The longitudinal curvature is pressed into each plate before it is offered up to the skeleton. This is a skillful job, as it relies largely on the eye and experience of platers. Plating is started from the middle of the boat, and each plate is set along the keel at a slight diagonal. It is marked out much like a lino tile, cut to fit, and then tacked into place. Unlike the British steel boats, light blue is built upside down, utilising the force of gravity in the bending of the plates across the T-bar sections. With the plate clamped round the curvature of the hull, the edge is tacked to the adjacent plate. To ensure a smooth joint, a scrap section of flat is tacked onto the fixed plate and then used as a lever to pull the new plate down. Phil uses a small metal rule to inspect his work. The lever is then broken off and moved 10 centimetres further down the joint, and another tack is made. A slow but important process which will determine the fairness of the hull and, if done well, will reduce considerably the amount of filling and fairing before painting. Once the seam is tacked along its full length, Phil moves inside the upturned hull to secure the plate to the all-important T-bars. A handle-like loop is tacked onto the new plate either side of the T-bar. A wedge driven with hammer between the handle and flat of the T-bar pulls the plate against its outside edge. The inspection lamp is used to make sure there is a good contact the full length of the section. The plate is then tacked to the T-bar. Eventually, when the hull is fully plated, the plate joints will be welded up along the entire length, both inside and out. The top weld to the T-bar will be done when the hull is turned over. Although the flat transom plate appears relatively easy to fit in place, it created probably the most skilled part of the plating process when fully fashioned. Light blue's gentle curves and total lack of sharp edges, normally associated with steel yachts, are a credit to Phil, Dave, and the craftsmen at Sirius Yachts.
The 9th of March, my birthday. There's a nasty tension in the air, as it's today we'll turn the boat over. No one quite seems to know just how things will go. So far, in just 3 months, we already have a complete hull. Add one deck, paint, and I'll soon be at sea.
So what do you think, Brian?
Super. It's all gone very, very well.
She looks good, doesn't she?
Oh, yeah, very fair.
Fabulous. I don't ever want to see her out that way again.
No, I don't think she will be.
Great, good. What next? Going to take her back inside?
Going to lift her up in the air again now and take the rings off, put her on the trolley, and then get her back into the shed.
Now start building the inside.
That's it.
Great. Terrific.
David, it's the first time you've seen her. What do you think?
I'm very pleased.
It's very pretty, and the steel work is very neat, and there's going to be hardly any filling and fairing needed for that steel work. Very pleased indeed.
Thank you. And I was just asking you about the skeg here, David. Were you ever tempted to go with a spade rudder?
No, we use spade rudders for racing, but I must say that a skeg rudder once got me out of the most dangerous situation that I've been in a yacht. And entering a harbour one night in breaking seas, when two of us managed to control the boat with a skeg rudder, I don't think that night we would have got through it with a spade rudder. I think it would have stalled, and we'd have very likely ended up on a big rocky breakwater. This engine is now definitely the Yanmar 3GM.
Right. Yep.
There are some things about the transmission that I want to talk through.
Mm-hmm.
We can either go to the traditional, rather hefty, the rather hefty skeg that causes an awful lot of drag. We can go to a P bracket and a bare shaft, which is minimum drag for this boat, which has got to race from time to time. Or what I would like to do is a combination of the two, really, which is a much lower drag, a much smaller skeg. But I'm a little bit worried about welding the propeller tube to the sides of this skeg, as you can see there.
So what size tube can we
The
use?
big self-feathering autoprop propeller needs a strong
50
skeg
mil
with minimum drag.
inside diameter tube, and probably a nice heavy wall, about 10 mil wall thickness, to keep the welding under control. Quite a heavy tube, and the sides of the skeg would be 4 or 5 millimeter plate, but I'd like it welded down the side here, rolling over onto the top, and both sides of the skeg coming together down the trailing edge, which gives a nice flow onto the propeller. And it's much better than this more traditional skeg, which has a big bearing carrier on the back of it, and it has to be about 80 millimeters wide, and it's a very bad drag onto the propeller, and it slows the yacht.
But I don't think there'll be any problem whatsoever in doing
It'll look
that.
pretty pretty.
It should look very good.
Once back inside the shed, the next job was to weigh the lead ballast, evenly fill the keel cavity with ingots, leaving enough lead to smelt and cover the ingots, solidifying the whole lot into 3,000 kilos of righting ability. Once this job is done, a plate is welded over the top of the ballast with a core plug in it. Any air left within is replaced with oil and then sealed off. With the deck now on, the frames for the coach roof were welded into place. There was much discussion between David Thomas and Phil to get exactly the right lines. plates are cut freehand with great accuracy. It looks easy, but in reality needs dedication to detail and the skill of a surgeon's knife. All joins are radiused, giving a nice gentle line, again welded inside and out. With the frames removed, the interior volume of the hull can be seen. The blue welding torch gives it an unearthly feel.
After 6 weeks in America filming the World Cup, I'm concerned things are slowing down. Many suppliers have caused delays, and we're now at the end of August, already halfway through our 16-month schedule. I'm going to have to shake things up if we're to make a March launch. David Thomas will be up today. I have to sort out with him the incorporation of the Hydrovane self-steering gear. I'm determined this will be part of the cockpit and not bolted onto the transom.
Brian, hello.
Hi, Ron. How are you?
All right, how are you? I've been looking for you everywhere.
Well, the rest of the paints arrived this morning.
So, Brian, tell me, when are we going to start spraying?
In a fortnight's time.
Another fortnight?
Yes.
Now, I'm getting really worried about launching on the 9th of March.
Unfortunately, we aren't going to make that date. It's...
Is there anything we can do to speed the process up? It's
not
really important to me.
We've, as you know, you've altered the spec a few times. So we've then had to take things out and go back to square one. And if you want a quality job, you're going to have to wait that extra bit. We'll make the end of April.
Yeah. We could save some time, obviously. You know, we were planning on going down the river and rigging in Gloucester, and then I was going to do my qualification leg for the Azores round to the Solent, round Land's End. If we take the boat down by road and launch her straight in the Solent.
I think that's a much better idea. As much as I would like to rig her in Gloucester and take her around the Land's End, I think it's a much more sensible idea to go to.
David Thomas
David's there. You've got the electronics man, Gary. He's in the marina.
And Kemp's.
Yeah.
Waterhelm.
They're all on.
Hood. They're all
there
in the
on
vicinity.
hand for doing everything that needs to be done.
What an exciting moment. Years of dreams encapsulated in one lump of metal. The stainless steel tow rail and stem head look great. No bolts, no leaking deck joints, no delaminating bulkheads, no osmosis. You can now see where over 400 litres of fuel and water are going, deep down in this voluminous hull, below the waterline and under the sole. The accommodation still has 6'6" headroom throughout.
Now we've come to the most important stage, I think, in terms of protecting it against the harsh environment she's going to live in. Can you explain to me the process that is necessary to do this?
Yes. The process is that this first coat, what we're going to do now, is probably one of the most important parts of painting steel boats, because if we don't get this part right, everything we put on top will be a waste of time and will probably fall off. So we have to, first of all, the boat has to be blasted to a Swedish standard.
Shot blasted.
Shot blasted to a Swedish standard SA 2.5, which is basically bright steel and profile. And having blasted to the standard, we then have to apply a coat of holding primer to hold the blast so that the surface will not oxidize. It's very important, and it depends largely on the conditions that you're doing it in. You may be able to blast all day and then apply the primer late in the day, or if the conditions are a little damp, then you might have to apply after about 2 or 3 hours.
How do you check those conditions?
Well, we check those conditions using a whirling hygrometer, which is here.
Richard, what's this called again?
That's called a whirling hygrometer.
Looks a bit like a football rattle.
Football clapper, that's right, yes.
And what does that do exactly?
Well, that tells us the wet and dry temperatures. From that, we can then calculate the humidity that we're going to be working in, and also the dew point, which of course is very important. With dew points, you may have a temperature of a dew point of 14 degrees centigrade, which means that the steel temperature must be at least 3 degrees above that, so that you're not developing any moisture on the surface. And we measure the steel temperature using a surface temperature gauge like this, and the probe is placed to the surface like that.
So, given the right conditions, you then apply the paint by hand?
The paint is applied by a spray. A typical equipment would be this, which is what we call a pressure pot with a conventional gun, and we would spray the primer onto the surface using this. The first coat is epoxy primer, a holding primer, which will hold the blast and stop any flash rusting. It's very important when you're painting steel boats that the paint is applied according to the painting specification. So therefore we have to make sure that we're putting the correct thickness of primer on. When we first start applying the primer, we would measure the wet paint thickness using one of these.
It's like a dog's
tail.
tail.
That's right. It's a combed, calibrated combs.
And each of those little indentations there are different millimetres.
That's right.
Or microns, probably.
Microns, that's right. And the comb is placed into the surface of the wet paint.
Yeah.
And then the measurement is read off according to the thickness you require. Once the paint is dry, we then do a second check with what we call a dry film thickness gauge.
Yeah.
And in this case, we use a instrument like this, which again, an electronic dry film thickness gauge, and the probe is placed to the surface like that, and you read off the thickness of paint off the display.
And if the paint is not thick enough, you apply another coat?
If the paint is not up to the correct thickness, we would apply some more paint until it is.
And then the top coats are applied. How many top coats?
Well, over the filler, we then have to apply more primer first before we apply top coats.
Yes.
And the filler has to be screeded onto the surface to profile the boat.
Right, and that really smooths out any imperfections in the hull.
That's right.
How many top coats go on?
Top coats, we apply 3 finishing coats.
3 finishing coats?
Yes.
And they're fairly high build, I would think, are they?
Yes, they're average about dry film thickness of about 38 microns.
38 microns. And once you've got that on, you've got protection.
Then you've got protection for a long time.
And gives you a finish as good as a glass boat.
It will give you as good as a glass boat, maybe even better.
Really, good.
You talked about balloon boats. We then had the boat show boat, the production yacht that was sold at a boat show, when the potential owner and his wife came on board and walked around the boat upright at a show, and they both liked the idea of it. They didn't look at the rig very much. They probably didn't walk around the mast, but they bought the boat.
That's right.
Because of its interior.
With the steel hull, deck and coach roof completed, shot blasted throughout and primed, the interior fit-out commences. The first job is to completely line the inside of the hull with a marine plywood skin. The bulkheads are also marine ply and can be placed anywhere throughout the interior, as they are not structural. The skin is screwed to wooden battens, which are bolted to the flats of the T-bar stringers. The whole hull has been previously sprayed with high-density foam, giving 2 inches of insulation above the waterline. This gives superior protection to the primed steel and eliminates contact with condensation or air, which are the basic elements of corrosion. Below the waterline, the bilges have been given 4 coats of VC tar.
When we bolt these winches down onto the deck,
the Lumar deck gear must all go on before the deck head can be foam sprayed and lined. Where retaining bolts are inaccessible, the deck is thickened, and the fittings are then machine screwed into it, making them easily removable for repair or replacement.
We start off on the port side of the boat, because all ropes lead on to the starboard, the right-hand side of the winch. Anything that works on the port side of the boat basically will work better on the starboard side. Some of the winches are not symmetrically placed from side to side. They do the same job on each side of the boat, but they're in slightly different positions because the rope always goes on to one side of the winch. What we're doing now is to double check the position of these clutches against the winch with a halyard passing through and going to the winch. And what we have to ensure is that the clutch doesn't get too high. So we have to make sure that the clutch is down below the winch, so that the angle between the winch and the clutch is right, and everything runs smoothly when the line runs onto the winch, and we don't get any riding turns.
Light Blue's mast is made in two pieces. If made from one section longer than about 12.5 meters, it's unlikely to have an anodized protective layer thick enough to satisfy the British standard for marine use. The join is a critical part of the structure and is held together tightly during assembly. As almost all of the loads in a mast are compressive, it is essential that the two pieces butt together precisely. The fitter takes care to align the tubes by hand. A small jig is fitted into the rear sail track and the process repeated. Once he is content with the alignment, temporary side fastenings are fitted. The initial rivet holes are now drilled. The main rivet holes are drilled, following a detailed pattern. The pop rivets are made from Monel, a highly corrosion-resistant alloy. If normal DIY rivets were used, they would self-destruct in months. Spreaders are attached using cast brackets, which distribute the loads around the mast section. The spreaders are temporarily attached during assembly to ensure correct final alignment. The brackets are locked together at the front with a dovetail and held firmly in place whilst the rivet holes are drilled and the rivets set. The aft rivets are then fitted. Shroud attachments are another vital part of the mast structure. The best way to transfer the shroud loads to the mast wall is via a fitting which is set into a large diameter hole. After coating with an anti-corrosive paste, the cast stainless steel fitting is posted through the hole. What happens next is the mast assembler's secret, but the end result is a fitting held in place ready for the rivets. Here a special splice is being created, which connects an easily handled rope tail to the low stretch wire part. The rope is made from two concentric braided tubes. The inner braided tube is then gathered into bunches and spliced onto the wire by tucking round groups of strands. Once the inner core is spliced into the wire, the outer sheath is pulled down into place. The process is now repeated, with the sheath separated into bunches and spliced into the wire. As the tucks continue, the bunches are progressively tapered. This wire-to-rope splice will run smoothly over a sheave at the top of the mast and is used in the main and jib halyards. Finally, the stray cut ends are smoothed with a hot blade. The ultimate test is to run a hand down the completed splice. Any stray wire strands would make their presence felt. Before the halyards are fed into the mast, light messenger lines are reeved. The lines are attached to a small sledge which is then pulled along the mast. Cross lines at this stage could bring problems for the yachtsman later, so great care is taken. The mast head box is loosely fitted, and the messengers run round the sheaves. Finally, the head box is positioned and secured. This is one of the few three-handed tasks during mast assembly. Wire for the standing rigging, stays and shrouds, is stronger and less flexible than halyard wire. Uncoiling it directly onto the workbench avoids serpentine handling problems. End fittings are usually attached by the roll swage process, involving a powerful hydraulic ram. The terminal, with wire inserted, is pulled through rolling dies by the ram, the small handle controlling the process.
So David, tell me, this is a single line in-mast reefing system that's a speciality of Kemp's.
Yes, the in-boom reefing system.
In-boom, sorry,
Yes.
in-boom. And tell me, how does it work?
It works by having one control line going back to the cockpit, which controls the tack and the clue line for each reef.
And this is what? This is a car that runs inside the...
That's right, it's a car that runs inside the boom. It runs on small wheels.
These are the things you gave me here.
That's right. They fit into the bottom, into these little slots on the car, and they engage in these slots on the boom.
And there are two of these, one either side?
One either side. One for the first reef, one for the second reef.
Right.
And
okay.
because they run in these little grooves, they can pass each other without capsizing or tangling with each other.
Okay, shall we put it in? I'll put the little wheels on for you. There we go.
Okay, Ray, if you just pull through. And on the blue.
Once that's in there for good, is it?
Well, it's going to be fastened in. I mean, you could remove the fasteners and you could take it off if you ever wanted to do anything.
If you wanted to renew a reef line, you just take a mouse through.
Put a mouse through and you can pull it on
through. And then you
through.
can pull through a new reef line. Right. Shall we go and have a look and see what happens? So, David, we're now at the mast end of the boom. Explain what happens here.
Well, here we've got the tack lines. They were attached directly to the clue car we saw going in at the other end. This will now go up and attach to the kringle on the sail.
It's pulling down your first slab of reefing.
That's right.
And this goes back to the cockpit through a turning block. And this is your second slab. Now, what about your third slab?
Well, we can't take a single line in reef in on the third because we're limited with the amount of movement we can get in the boom of the cars. So we have to do that on a conventional clue line and a separate tack line.
This third block here.
Come through out from the bottom, going back to the cockpit. It's just going to pull down the outer end only.
Right.
And we have to take down the tack end with a separate line running through some leads on the gooseneck bracket, which is on part of the mast rather than part of the boom.
Right. And what's this jammer here for?
That's for the foot out haul.
I take over when the lumberjacks are finished, chopping the branches out the tree. Getting a good finish on the wood ready for varnishing.
The interior fit-out is well underway. As with any quality construction, the labour element is all important. The many skills required need to be project managed, or they often end up waiting for equipment or tripping over one another as they try to work in the same area. The size of the boat limits the number of craftsmen who can work on the interior at any one time. Light blue has much solid interior woodwork, which all needs to be prepared and varnished, while the cockpit and helmsman's seat are planked in teak on top of the deck. Marine ply is first stuck to the deck to enable conventional fastening methods.
6th of May. Smiles all round as Light Blue sees daylight for the 3rd time. This time, she'll get her bottom wet. I'm afraid you're not going to see her launched. I ran out of film.
I go sailing with customers in their existing boats, and they have most awful weather helms and nasty rigs, and you know, these people have been using those boats and sailing them for years and not really understanding how bad they are.
Yeah.
Everybody lays a lot of the blame at the racing design influences, the IOR rule, which to a degree is true. You know, it is guilty.
It certainly is a big stick. Deck mounted. Twin sweatback spreaders, BOC style inner forestay, twin backstays with running backstays for windward work.
The thing that excites me, I think, about the boat most of all is the success of all the details that have gone into the design and the build of the boat.
You know, I'm happy with the way she is now, very happy, and all the details add to that. And the things like the which are down to Drummond, the nice piano hinges on things where otherwise would just be a couple of miserable little hinges, and the beautiful woodwork that Brian has put in, and the care he's taken in matching woodwork on different sides of the boat, and the feel of the boat down below and on deck, I'm very pleased with.
Yeah, she's been put together to the very highest standards, really. I think the lovely light interior too works very well. All this white painted wood relieved by the varnish work looks very, very pleasant.
And really, I suppose the only reminder that she's built of steel is that.
Yeah.
It's the only steel that you're aware of, but even then you're not sure till you actually touch it.
After rapid sea trials, Light Blue was put to a serious test with a sail round the British Isles. While there were a few problems, she always sailed superbly. She has probably the longest legs of any boat around of her size, up to 3,000 miles range under power, an Aquafresh water maker that can produce 25 litres per hour, and a sail wardrobe to meet all conditions. Below, she has an outward-facing navigation area with a full complement of auto-helm instruments, including a nav center and radar with ICOM VHF and SSB. All instruments are linked by SeaTalk, which commands her powerful hydraulic auto-helm 7000 steering system.
I mean, yesterday's sail for me was fascinating because here we have a boat that is so wonderfully seaworthy and so heavy. She has such a nice steady gait in the way she sails.
I mean, being a steel yacht, she has to be a heavyish yacht, and I have to come out, I think, and say that I favour heavy displacement for serious, long-term, liveaboard type cruising.
Yeah.
Real cruising.
Well, the astonishing thing I found yesterday was that, for all the fact that she's got an enormous rig on her and she has got a towering mast, she was so stiff out there in winds of between 25 and 30 knots, we were still carrying full mainsail for much of the time, which is almost unheard of on a modern boat.
I found that you could sail her to windward at different speeds. I could sail her to windward at 5 knots for the same sails. I could sail her to windward at 6 knots and she was still quite happy, or I could strap things in a bit and get her up to 7 knots, so that you can make the boat operate in whichever gear you choose.
Yeah.
And that helps to keep the boat comfortable.
Yeah. But the other thing I like about it is she has a nice substantial feel wherever you walk around. A lot of modern boats, you walk around them and there's a slight sort of flexibility and a little bit of squeaking here and there. On this boat, it just doesn't squeak, it doesn't move. Everything is monocoque. It's terribly strong, which is, she'll be around for a long, long time.
I have to say it's a tough undertaking to build a boat from scratch. When you get what you want at the end of the process, it's all worth it. For me, I don't want to leave Light Blue's wheel at the end of a watch. She really is an exciting boat to sail.